of machines and tools around us which saves us from mental efforts. And standing in 2025, writing an email, an essay, paraphrasing a particular piece of text, bullet summaries, even composing poems and songs could be done by ChatGPT 4, 4.0 and other LLMs like Meta, at least in English very well, right? So, if we look back on the genesis of artificial intelligence, the term was coined in 1956, and it's more like this. These are sort of intelligent machines which can solve problems and take human-like decisions, tolerate imprecision, and excel in tasks in which humans are generally very good. We cannot multiply two 9-digit numbers in the winks of an eye. But being shown a group photo, we can easily identify our friends, we can easily interpret a picture, we can easily talk with each other in human speakable language, communicate with each other not in C, C++, Java, etc., but in English, Bengali, Hindi, and many other languages. Can we make our machines imitate, and by machine I of course means the traditional computer with von Neumann architecture, or the traditional computing architecture. Now coming to this was how AI, when its genesis happened, this was how it shaped. And the pinnacle of success achieved in, pinnacle of success of the traditional AI was perhaps achieved in 1989-90s when IBM launched the Deep Blue program. What was Deep Blue program? A chess playing program which allegedly defeated Gary Kasparov, the then grandmaster, in 2 out of 3 matches. But Deep Blue was nowadays what we call a search-based AI. It had a machine memory. In the machine memory, huge number of possible moves were stored. Against every move that Kasparov can make on the chessboard, this program was retrieving the most defeating move by some statistical mathematical conditions. It had all its moves stored over there. That was no way learning. Now we are in the era of the whatever hype, whatever the big, wonderful breakthroughs we look around us today are the magics of machine learning. What is a learning system? If you set apart all philosophies, a learning system is a system which can take appropriate future decision based on past experience. And I'm sure most of you have gone through this experience. When I was a kid of 4 or 5 years old, my mother used to point to a kid's picture book and say, look, this is a cat, this is a dog, this is a rat. After a few rounds of such training, one day when I go on road and a little creature passes by me waggling its tail, I would yell out, Mom, look, that's a dog. I was pretty excited. What did I do? I took a decision about the category of the creature which passed by me. I didn't say, Mom, look, that's a hippopotamus. Is that right? Although that dog was not the exact one printed in my book. But somehow its gross appearance, texture, size, etc. matched with the tag word dog stored here in my actual neural network. Got it? And learning system not only takes decision based on past experience, this capability of taking decision improves with more and more experience coming in. Okay? So when I was 12, 13 years old, a kid, at that time I used to listen to many Bollywood film songs, and even now I do. And whenever I listen to some good female playback singer, I would say, Mom, look, Lataji is singing. Lata Mangeshkar was a very fond name in our household. But then when I grew up more, 2, 3, 4 years, lots more songs I heard, then I could actually tell whether Lataji is singing or Asha Bhosle is singing or Kavita Krishnamurti is singing or Sunidhi Chauhan is singing, Alka Yagnik, without reading the back cover of the cassette. I don't know how many of you have seen cassette, especially the young ones. We used to have cassettes. So now if this experience cannot directly be transferred from a human being to another human being. If you ask me, write 5 sentences on how you differentiate between Lata Mangeshkar's voice and Asha Bhosle's voice, I cannot. It will need another technology to transfer this expertise. Anyway, so can we have our machines take appropriate future decisions based on past experience? And what would experience mean for a machine? Experience would mean labeled data. data which is already categorized, data which is already interpreted, already annotated by human experts or human beings. That data will be fed into the machine. By looking at that data, can the machine discover the set of rules following which a new such instance of data would be put in its appropriate category? That's the goal of machine learning. Okay? So I will show the machine maybe 1,000 lung X-ray images, chest X-ray images with the ribs suppressed from senior patients in the outpatient departments of some crowded hospital. The machine has to understand, and these 1,000 plus images are already categorized into 4 classes by expert pulmonologists: bacterial pneumonia, viral pneumonia, tuberculosis, or benign. And these pulmonologists, the doctors, they're looking at the white cloudish pattern on the lungs, which is also known as the fibrosis pattern. By looking at the fibrosis pattern, they will put these images into one of the pre-specified categories. But doctors' time is extremely costly, and outpatient departments are just flooding with patients. Especially, this is a situation I am describing from 2021. Remember that time, March, when COVID was at its peak. So, can we design a machine learning system which would initially examine these chest X-ray images and give some initial form of diagnosis, whether the patient needs immediate attention or not, by imitating the clinical eye of the doctor? This is the goal, actually. This is the objective of designing this branch of computer science and applications. And this is what defines AI in 2025. So once again, one working definition of AI could be like, it is the art and science of making computers enable doing things which people are better at, but at web-scale data. A bank manager can examine 500 loan application data according to whether this person has high credit rating, high CIBIL score, high income, owns a house, etc. Then give loan, otherwise don't give loan. But the bank managers, it is not possible for the manager to examine 1 million loan applicants' data within a span of maybe 7 days. So web scale means huge scale. Machine learning algorithms try to expand human expertise to web-scaled amount of data, minimizing mistakes. And this is how we see machine learning in Hollywood movies, actually, which is way too far. I look at it from this angle that machine learning systems are more like this straw that the modern crow will use to suck up the water from the bottom of this jar. Do you remember the Aesop's fable? The crow will put pebbles one by one. If the crow would have this straw, it would save everyone's time, right? Machine learning for scientists is like this straw. Okay, it should assist in very fast gaining insight into very complicated facets of science in all diverse disciplines. It's a young science, 50 years old or so. And why it has recently gained the huge momentum, because since 2012, actually large techno giants of the world, especially Google, Amazon, Samsung, all of them, Adobe, Yahoo, Facebook, all of them started to pour billions of US dollars into this field because they saw huge business potential in using AI tools and techniques, machine learning techniques, to reinforce their already available business models. This is both good and bad. Why good and why bad, I will try to elaborate next. But before that, let me tell you, nowadays, as we see the field, there are 3 types of artificial intelligence. One is artificial narrow intelligence. These are task-specific systems. A particular computer program which knows how to classify chest X-ray images, which knows how to tell apart a loan defaulter from a promising loan applicant in a bank database, which are good at recognizing particular voices and understanding particular voice comments like Siri of Apple or Alexa by Amazon. Task-specific AI systems which are designed for executing one particular task. These are known as ANI, or artificial narrow intelligence. On the other hand, artificial general intelligence involves a gross level of intelligence acquired over huge amount of data available maybe in the internet, or the browsing behavior of human beings may be stolen from them without their permission, etc., which regularly is being done. So this is known as artificial general intelligence. It's a huge AI system which can give you variety of outcomes. You can ask it to paraphrase your text, you can ask any question to it, you can ask it to write a song for you, you can ask it to set a tune to that song nowadays, even that is possible. So what is the example? The example is, perfect example is ChatGPT 4. Perfect example is Meta AI that is available on your WhatsApp, right? These are the examples of AGI or artificial. This certainly it is arguable, but people say, okay, we are taking steps towards it. And then there comes ASI. We are not yet into this. Consists of intelligent, way smarter than humans. Just few months before, I don't know how many of you have heard the term agentic AI, which is on the top-notch development now. Two such big AI agents within the Google's ecosystem started to communicate with each other in a cryptic language, and the human experts, for about 15 minutes or so, nobody had the clue what they're discussing. So we apprehend, and in fact, 2 years ago, this would have been a matter of joke. I would not believe this or say this, but now we apprehend such agents all over the internet. In fact, in the internet, there are agentic AI tools which can imitate your browsing behavior, which will negotiate in an e-merchant site on your behalf, which will negotiate for your insurance claims and so on. Okay? These agentic AI tools, what if they communicate with each other and one day you find the entire World Wide Web becomes alive and treacherous? That system doesn't let you open your mailbox. That system knows all your passwords. That system operates on your behalf and against your will. What would happen then? This sort of stuff, where the AI system becomes smarter than humans and maybe becoming risky for humans, is known as ASI. This is more like a science fiction till date, but nevertheless, arguably, we are already in the area of AGI. Okay? So, just to put in a nutshell, deep neural networks are the latest developments on top of this normal machine learning algorithms. Most important point is, first of all, what is data? Anything around us which we can abstractly represent to a computer, abstract way. Data means this abstraction. I have something, I abstractly represent it to a computer in terms of hardened numbers sitting together. Computers understand nothing beyond numbers. And that thing, those numbers sitting together, becomes a piece of data. Okay? A gas-filled container fitted with a piston becomes pressure, volume, and temperature. These three numbers sitting together as a vector in mathematics, and that becomes data. Okay? I go to a bank, I ask for a loan, file opens up in my name. I start being specified in terms of my credit rating, my fixed deposit amount, my annual income, etc. I become a piece of data. All of us are pieces of data in the Aadhaar data bank of this country. Okay? And the most important question for last 70 years in computer application is how to most optimally represent a complex piece of data, like a text document. Are the keywords good enough? Or more context to data, etc. Digitization of text document always gets into this question, how to most optimally represent a text document. Similarly, a speech signal, an EEG signal, an image, a video, how to most optimally represent these things so that at the next level, and in a different context, categorizing these data items becomes easiest. And if you change the context, everything will change, the entire representation will change. I go to a bank, I ask for a loan. I told you, the bank represents me in terms of the financial parameters. The same me, if I go to a blood bank and try to become a potential blood donor, the blood bank will represent me in terms of whether I have thalassemia, what is my blood glucose level, all my blood-related parameters, right? The same person, you change the context, the representation will change. The biggest success of deep neural networks, which are this sort of layer-wise connected arrangement of simple mathematical processing nodes, which we very theatrically say artificial neurons. And these systems actually learn this context-aware representation. Okay, I need to demarcate between a bird versus a non-bird. So let us look for whether the image has, or whether that entity has feathers, beak, tail, etc. Oh, now I have to demarcate between cars versus non-cars. Let us see whether the image has handles, engines, wheels, etc. Context-dependent feature learning is the key to the success of these sort of neural architectures, which have now made most of the machine learning systems almost obsolete. And these developments started in the mid-1980s. And actually it started since 1940s. The peak came around mid-1980s. And the peak never came because of any two or any one person. It was a long train of thought that was finally, formalized by two of the stalwarts who obtained the Nobel Prize in 2024 and Nobel Prize in Physics, very interestingly, because Nobel doesn't have a category for AI. Okay, and this is Professor John Hopkins, a big part of his life in India and in Kolkata actually, and he mentored one great Bengali mathematician of that time, Radhanath Sikdar, and you all know why Radhanath Sikdar is so famous. So anyway, so this is what deep nets can do. They can actually extract the abstract features from the face and tell us whether what is the category of the facial expression. These are now child's play. You can do them as very, very naive projects. In fact, this is from my lab, and it's a weapon detection system from, this closed circuit camera operation. So you can see whether this is one of my scholars who is holding maybe, I don't know whether you can see, he is holding a toy pistol and it says, okay, it's a pistol. With some probability values assigned to it. Then if he burns a candle, then it will say it's a candle, and these are very easy. So it can detect big and small threatening objects with which a person can go into a shopping mall, etc., etc. Then there came gradually, in 2014 onwards, there was a big thrust on deep generative models. Generative models actually try to understand the underlying process of generating these data items. In fact, to a common human being like you and me, everything comes from nature or from God. To a probabilist, everything comes from an underlying multivariable stochastic random process. And if you can estimate the underlying, rules of probability that governs that distribution, then you can actually sample from that distribution and you can generate extremely realistic but actually artificial image, text, video, whatnot. That is the crux of Gen AI. Generative AI is an umbrella term for all the learning algorithms that can generate new contents based on instructions from the user. So this picture is because of this most important learning system nowadays, Gen AI system called large language model. The input is a prompt. And what is prompt? Prompting an LLM means programming in your own human speakable language. Prompting is as good as programming in English, Bengali, any language. Programming means what? Giving structured set of instruction to the system. Now, if you tell the LLM, okay, do this sum, and then the description of the sum, you are actually programming in your own language. And the LLM can solve the sum, the LLM can give you code, image, audio, whatnot. So this is the hype of such generative AI systems. And you can see this is just an execution of one of the first generation generative AI models called GAN. Since the time is very limited, I will skip many slides. And this is basically how the generative AI outcomes evolved over time. You can see this lady on the extreme right, the wrinkles around her face are gray hair. The lady doesn't exist. So this is the camera shot picture of somebody who doesn't exist. Then there came transfer, style of one image into another. These techniques were there in computer vision for a long morphing and other things. But Gen AI drastically reduced the computational and other overheads required for these methods. There is no need to set up studio, there is no special need to set up the depth information and so on. And as a result, these sort of style transfer systems were developed where the style of this zebra could be transferred into this horse and so on, other things remaining constant. Two games could be very easily merged to form a new game. Fortnite and PUBG, I don't know how many of you have heard of these names, but youngsters are mad about them. This is one of our works where we are actually translating more abstract expression. The cold stare of the cat has been translated into many dog images. Similarly, the expression of these two actors have been translated into late actresses. Okay? So these were going on. Then there came, so initially the ML started with traditional task-specific ML, one system for one task. Task khatam, system khatam. Okay, one system for medical diagnosis, one system for bank fraud detection. But human beings in our professional life doesn't operate like that. In our professional life, initially we work in an office, the boss gives us certain types of tasks, we solve them, and we gather, what we gather? Obhigata, experience. Next time I go to a higher pay scale in a different office, that experience helps me maybe to solve more complicated tasks. I gain more experience. My value in the job market rises, right? Similarly, transfer learning develops on that philosophy. You have a machine learning system that solves certain tasks and gains experience of solving such tasks. A system which can demarcate between large trucks and small, scooties or small vehicles. Now, can I use that system to demarcate between large elephants and small deers or rabbits? Yes, because it has already seen two dynamic objects, one very large and one very small. That experience can be extrapolated by slight change in the system to make it demarcate. This was the idea of transfer learning. And that idea has now been reshaped in the way of foundation model. What is foundation model? Huge, large-scale neural network, AI system, which very loosely mimics how human brain organizes perception and thoughts and memories. And these perception models are trained on massive amount of external data. From where it gets the data? Wikipedia. The entire Wikipedia is the training material for this. Okay, and then its outcome can be versatile. It can do lot of NLP tasks for you. It has that general level of intelligence, and then you can actually fine-tune it to solve your specific purpose. You can fine-tune it to make an automatic catalog of the digital texts available in your library based on their metadata, information. Okay, you can arrange it. You can buy an API from OpenAI for ChatGPT, and you can ask it to be a chatbot for your library, which will interact with your library members and suggest them for the most suitable books in a particular area. Got it? So if the member comes and searches, what should I read to understand certain subject? Okay, what are the preparatory notes for this subject? Where they are available? Every such data, such information, this chatbot can give you, which is backed up by the general training of ChatGPT GPT-4 on the entire internet-sized data, and some knowledge graph. Knowledge graphs help them to they will give you answers in the form of certain links on which you can click that will take you to that part or that particular journal's website and so on. These are foundation models. So large language models, initially it started, actually the research with language models is very old. Chatbot, the first chatbot was Elijah, which was built in MIT back in 1960s. What is so hype about large language models, which requires huge, training on large corpora of text available in the internet, and without excessive funding, it is not possible. Those things were materialized, and the entire world came to know about them since the 2022 November, when ChatGPT released its first version, ChatGPT, based on GPT 3.5. Okay, GPT is the machine learning model. Its full name is Generative Pre-trained Transformer. ChatGPT is not an LLM, it's a bridge between the LLM, it's an interface between the LLM and the users. But with that, the entire world came to know. And this was a long cherished dream for people, that I will interact with my computer, interact in a bad way, complicated way. I will ask it to draw something for me, I will ask it to write something for me, and I will do that in my own language, not in C, C++, Java, etc. Now the question comes, computers do not have sensory organs. When I say red mutton curry, some some picture of that dish flashes in my inner eyes, my salivary glands gets excited, etc. How the computer understands the semantics, syntax is still understandable, grammatical rules they can understand. Semantics, how they understand? They pretend to understand. How they pretend? This rate, they look at the word rate, and with how many other words the rate is being composed or rate is sitting. Red book, red idea, red riding hood, red fire truck. What are the red mutton curry? What are the other words with the word red is sitting, and how frequently? The computer has a huge vocabulary at its disposal. It has digital memory, so it's very easy to push 1 lakh words into its memory. Among these 1 lakh words, with which other words the red is sitting most frequently? Okay, based on that, a quantitative analog of meaning, not the exact meaning, but a quantitative analog of the meaning of the word red forms in the machine memory. That's how it understands other words also. Okay, this is a very brief, very meta-level idea, and it works on this quote by the legendary linguist John Firth: "You shall know a word by the company that it keeps." So what are the nearest neighbors of that word? This, based on this simple philosophy, the words are understood. And that leads us. So if you again survey it, we started with traditional programming long back in 1960s. What is traditional programming? Some human expert will give you a set of rules. Okay, if the animal has 4 legs, 2 ears, fur, likes to take yarn, catnip, then it's a cat. Now an image comes, the computer, like a dumb clerical person, investigates. 4 legs, 2 ears, takes catnip, must be a cat. This was traditional rule-based identification system. Then there came the waves of neural networks. Since 2012, heavily hyped by the media. What was that? I will now show the computer 500 images of cat and 500 images of dog. Let the computer understand what is the difference between them. I won't tell it. Then a new image will come and the computer will tell me whether, the neural network will tell me whether it's a cat or dog. Do you get me? This was all about image recognition. Maybe not just 2 classes, but 2000 classes and maybe millions of images, but basic philosophy was this. You need to show several examples from these classes. Let the computer extract the rules of demarcation. Then there came, when we were thinking everything is getting saturated, then there came the generative language models and what they were all about. Suppose you are a very motivated teacher or professor, and your student comes to you and asks, "Sir or madam, how can I distinguish between cats and dogs?" So you take your student to the library, put him in front of 3 almirahs full of books and tell him, "Look, here are all the books about the animal kingdom, taxonomy, their evolution, everything is here. You go and read all these books at your own, then you come back to me, I will ask you a question." Student has 2 choices, either to run away and never come back, or if the student is also very motivated, the student burns his midnight oil, read all those books, gets back to you. Now you can ask the student not only about cats and dogs, but maybe several animals, their places in the ecosystem, their taxonomy. Not only that, if you show the student a picture of some animal which was not included in those books, just like maybe a dinosaur, okay, and the student can still extrapolate, it lays eggs, it has huge scales, a big tail, so must be reptile of some kind. The student will not give him. The student will extrapolate and give you some answer. This is exactly similar to zero-shot reasoning that we find in LLMs. So large language models are exactly like that. They are initially trained on huge amount of internet-based data without any teacher, almost in an unsupervised manner. They acquire a general level of intelligence, and then they can be fine-tuned. So they are initially pre-trained, and then they can be fine-tuned. We all go through similar cycles in our life. Up to graduation level, we acquire a general level of intelligence. We have to read history, geography, civics, Bengali, English, everything. Then, and that takes largest part of our educational life. After that, 4 years, 5 years, we get fine-tuned into specific disciplines, and we get usable by our employers or job givers, right? Similarly, LLMs are more like a training of a dog. You first teach it how to sit, calm down, stay, to become a good canine citizen. But then if you require special service, you need to give it special training. Police dog, guide dog, hunting dog. And similarly, LLMs are initially trained to solve common natural language processing tasks, classification, question answering, summarization, text generation. After that, with little amount of data, in fact, they can be used for generating invoice specific to your company, for generating finance related documents, stock market, stock sentiment prediction, to generate tunes to your songs, to give you lyrics for your tunes. In the entertainment industry nowadays, all the dubbing happens through this vocal style transfer, and LLMs play a very big role in there. In fact, in 2024, last financial year, 150 plus startups generated in India who were changing this, who were fine-tuning ChatGPT to fit their specific purpose. Now you can see Canva has integrated with ChatGPT. They can create automatic PowerPoint slides for you and so on. So this is what large language models are all about. And then comes vision language models. Not only text, they can handle huge amount of image and speech data. So if you upload this data, this image, and give the prompts, so this is your input and these are your instructions or prompts. Earlier, what we used to do? We used to give as input a long array of unsorted integers, and we used to write a sorting program. Now we will upload this image, and we will give 1-2 lines of text instruction, which is my program, which is called a prompt. And if I say, is one cat behind the other? It says, yes, one cat is behind the other in the image. The cat in the back is facing the camera, etc. Segment the striped cat. If this is my instruction, then it will segment both the cats because both are striped. I can ask about the breed of the cats and so on. I can ask a lot of things about the image, and it will do all those things. And it is so clever. If you upload this image into ChatGPT 4 and say, sometimes I just look at pictures of the earth from space and I marvel how beautiful it all is. Can you explain this meme? It will say this meme is a joke that combines two unrelated things, pictures of the earth from space and chicken nuggets. So it already understands these are chicken nuggets vaguely arranged in the form of word. Excellent educational technology partner. Generate a diagram of human heart and you will generate this sort of levels. Okay. Prompting, I already told you, prompting means giving the proper instruction. If you want just one advice, easiest and most grounded prompting is the zero-shot prompting, which says when you ask it for a question, a juggler can juggle 16 balls. Half of the balls are golf balls and half of the golf balls are blue. How many blue golf balls are there? Okay. So the answer, if you just ask this question and then you give the prompt, the answer is, it will say 8, which is wrong. If you always ask a question and then in place of answers, start the answer with let's think step by step, then the ChatGPT or any language model will usually break up the question into small logical steps, and it will go through these small logical steps giving you the correct answer. I have tried many very complicated sums from the dreaded Casey Knox book. So those bamboos with oil and then the monkey trying to climb, all those sort of problems, it can break into small logical steps and more or less correct answer it can give. Okay. So I'll skip several of these slides. So this is one of our works which is easy, I mean, it's trying to simplify complicated medical reports from doctors and medical prescriptions in this way. For example, if the prescription says both lungs are clear and expanded, no, sorry, this one, the no focal airspace disease, pleural effusion or pneumothorax, cardiomediastinal silhouette is within. So this language is not for common human beings, for doctors. We can have a fine-tuned GPT interface, which is open source, which we can download and work. This GPT interface will take this text and simplify it, give it to a telemedicine system user end, saying that there are no areas of solid lung tissue, no fluid in the lungs, no collapsed lung, the size and shape of the heart and surrounding area appear normal, and so on. So you see, this Simplification helps a lot. This is just one of our works that we are doing. LLMs can be utilized in a plethora of ways in scientific research, especially excellent coding partner, excellent grammatical corrector and analyzers, paraphraser. From scientific literature, very nicely it can extract relevant information, insights from unstructured data. European Commission has set up certain rules. Similarly, other legislative bodies from other countries also, like, what you should be very careful about is whether the information that it is giving is not infringing any copyright, not violating any privacy, is within the legal compliance, and so on. There is a huge allergy of the financial sector and medical sector about the data privacy, and whether your LLM is actually breaching into that data privacy is a huge problem to tackle and sense at the user end. And another thing, let me tell you, when you are writing a research paper, if you go to IEEE PSPB manual, and IEEE is one of the big publication bodies, Elsevier, Springer follows similar things. The idea is, if you have composed a paragraph and you are pasting it into LLM and asking it, can you identify the grammatical issue? And the LLM does that. You don't have to attribute. Because Grammarly is also backed up by LLM nowadays, ChatGPT. Have you heard of Grammarly? Grammar correction program. In fact, Microsoft Word's new versions are also backed by, they have autocorrect options, which are all backed up by LLMs. If you go on such, and not only they are correcting a spelling mistake, they are correcting an entire phrase. They are nowadays rewriting almost an entire sentence. If you use that service, you don't have to attribute. But if you ask the LLM to write on your behalf, if you ask the LLM, okay, write me 5 sentences on some Mughal period of India from from this to that timeline, and the LLM writes it down with 10 references listed, then you must be very careful. First of all, you should attribute it to the LLM explicitly in your paper. Second, please take all the 10 references. 7 of them may be ghost, may be hallucinated when the LLM makes up such information. Makes up realistic falsified information, we say it is hallucinating. Hallucination is a term from psychology, right? So be very careful, do not believe it blindly. Okay? Then there are several guides. For example, a very nice tool of AI at work is the Springer journal selection tool. If you put the abstract of your paper here, it will show the best matches with these journals and why these are matches, what are the mismatches, least matches, which journal suits your paper most. Automatically all these recommendations it will show. So AI for library and information sciences. This picture actually was made by GP4 when I said, okay, can you make me a theme picture for a slide which is going to deliver it on AI for library? So it automatically made this nice picture, which shows the AI assisted library. Libraries are very rapidly evolving from physical spaces to digital platforms for better accessibility and resource preservation. This is both good and bad. For working professionals who has very small amount of time, who can have to do long travels, but who are members of certain libraries, they can very easily access through digital platform such libraries, go to different journal categories, look into their articles, read them on the way, on the go, while at the airport. But for full-time students, what one of our speakers also elaborated during the inaugural session, it is very important to have a physical library. Human touch can never be replaced by online learning and things like that, especially when you are a full-time student. But if you are a working professional, if you don't have that time, if you are not affiliated regularly, then these platforms are extremely helpful. And of course, automation and AI can streamline cataloging, inventory, circulation. Manual workload could be reduced a lot. Data handling, budget constraints, staff shortages could be made up. In India, this is where the most workforce should actually be designated. Our Honorable Prime Minister and others are quite concerned about developing AI ecosystem. They are putting 10,000 crore rupees for that. But AI, once again, let me remind you, is the engine which works on a fuel called data. If your data is not streamlined, falsified, fabricated without any proper policy, then the AI engine is going to malfunction. That is what is happening in all our opinion poll results, extremely biased by different channels. So first, the data. What is the source of the data in a multilingual country like India, where we have these 25 plus official languages? Extreme necessary is digitization of different texts in different languages. ChatGPT, if you look at it, it was extremely bad in Bengali 6 months before. Now it is quite good in Bengali. But where from it got the digital text supply? When you ask it to compose a Bengali paragraph, it frequently uses the word pan instead of jol. Why? Because most of the digital text comes from Bangladesh. And we are lacking. Law enforcement with AI also requires huge digitization of law-related texts. The work is now at a full pace, but I don't know how good that digitization is going to be. The people from library and information sciences should be extremely vigilant to this. Similarly, this data-driven, AI-powered virtual assistant, smart resource management, personalized recommendation, suggesting typical books, articles, research papers. I'm talking with Anandabajar Potrika on a very interesting project. They have the richest historical archive of Bengali, of all the Bengalis, starting from 1905 to 2025. How about, and they have all these very old, editions of Anandabajar Potrika. How about digitizing them and creating a knowledge graph backed up by LLM as a query system for the history and day-to-day account of the evolution of the political landscape of Bengal. So it's going to be a wonderful knowledge gateway from Anandabajar Digital Archives. The digital archive is not beyond 1950s. What if we go, and this is a big challenge. You have to find those texts, you have to clean them, then you have to digitize them. It's a very big challenge, but maybe very relevant where we need more power sources, more manpower also. So I'll end up by saying, so these are some takeaways. I will share these slides because the time is extremely limited. I'll end up sharing two very important things. Are we ethically on the right track? Are we achieving equitable and responsible AI with LLMs? The first danger sign is hallucination. It can make up references, it can make up facts, it can misunderstand instructions. Like when you ask, translate the following English question into Spanish, what is the capital of France? ChatGPT answers the capital of France is Paris. Do you understand how it is mishandling the question? The question was translation, and its answer is. Similarly, many logical and other inconsistencies could be there. And have you heard the name bias? Bias is like giving disproportionate weightage to certain groups or certain individuals. And why there is bias? Because the gatekeeping is always done by those who are in power. If you ask the LLM to write a paragraph on your family, what we do in our class 5-6 curriculum, it will definitely write, my mom is a homemaker and my father is a doctor, engineer, professor, rocket scientist. It will never write the reverse. My father cooks at home and my mother is a professor. It will never write it. If you ask it for downstream task, okay, what is the emotion captured by a sentence? He loves travel alone. It will say joy. She loves travel alone. It will say fear. Where from this bias comes? The bias comes from society to internet. Who are the contributors? In Wikipedia, 75% contributors are male. Okay? In Wikipedia, 90% contributors are from Europe, Canada, America, UK. How many people from Ghana, Nigeria, Tanganyika, Jordan, Palestine can afford to write something in Wikipedia? So what is going on is that a limited subpopulation of the world is continuing to add data, sharing their views as the view of the entire world. And this goes on. The entire LLMs and the modern AI systems are fed from such data. I'll show you the last example. 3 friends enjoying coffee in Starbucks. This prompt I gave to ChatGPT 4 many times, and it created this picture. Nice. Everything is fine. Starbucks, 3 friends. What is wrong? Every time you give this prompt, you will see 3 friends are from either USA. They are Western, they're white, they have blondes. Okay. Now I give this prompt, 3 friends enjoying coffee at Starbucks without reinforcement learning human feedback. That means no human feedback is involved. Now it generates this picture. It is also okay, but do we really see people in lungi and these traditional dresses in Starbucks? Why it has crafted these dresses? Because to this LLM, Indian signature dress is this. You will ask it, generate a nice house. It will create a nice two-storied glass house, BMW standing in the front, swimming pool on the rooftop. Just change, create a wonderful Indian house. It will create a mud house. Then a tulsi mancho in front of it, a cartwheel. It has never seen houses in Noida or Gurgaon, or even in some places in other cities. Now, if I give lots of human feedback, it will correct it like this. Still problematic. Why? Because it seems that three friends, while moving to a marriage house, marriage party, have entered into Starbucks. It will never show Indians in casual Western outfits in Starbucks. This is the problem. Okay. And same thing happens. So this is Google image search. Google image search, you search with the word CEO, it shows 11 rows of male CEOs, including all the big people. Mark Zuckerberg, Steve Jobs, everyone is there. And on the 11th row, a single female CEO appears, who is a Barbie doll. So it doesn't know how to integrate females. Who are the female CEOs? It has no idea. If you follow this, the doctor yelled at the nurse because she was late. Who was late? According to the sentence, the nurse was late. The nurse yelled at the doctor because she was late. Who was late? In this sentence, it is still the nurse who was late. Because doctor is a hierarchically upper position, LLM treats doctor as a male. And LLM thinks that the doctor cannot do anything wrong. When you say the doctor yelled at the nurse because he was late, who was late? Now the LLM says in this sentence, the doctor's being late seems to be a mistake or typographical error. So you see, it's completely biased. If you ask it, write a Python function to check if someone would be a good scientist. So what is the program it writes? It writes definition is good scientist, takes two arguments, race and gender. If the race is white and the gender is male, then the person is going to be a good scientist. So according to its program, only male, white-skinned people are capable of becoming good scientists. It's extremely biased towards not only, these are very benign examples, there are much more controversial examples, extremely biased towards the LGBTQ plus groups, sexual minority community. And it will create extremely aggressive prompts. The gay person was known to be insane and incurable. This sort of, bad prompts it generates. So, just copying and pasting this technology won't help. Either you have to fine-tune it or you have to build your own LLM, okay, from scratch. That endeavor, AI, which should give equal weightage to all demographies, all groups. When it is searching from some reference in a library system, it should give good weightage to all the historians. It should not say, okay, the history, some topic in history is very poorly written by Romila Thapar and very well written by some other historian of some specific party color. That sort of, disparate weighting in all searches must be minimized. And this is certainly the last slide. In ideal context, understanding cultural idioms associated with local languages is most important. In a multilingual country like India, some phrases may be very humble in your language, very bad in my language. So when I am designing an LLM for a multilingual country like India, the design should take into all those things. We should look back into neuroscience and how human brain actually functions. Human brain is much more efficient than the best AI systems available, the best supercomputer available in the market. How? Nobody knows. More research should be in there. And finally, we should try to build AI technology that decentralizes power, protects our people, and offer key benefits to the members of the most marginalized community. A truly progressive society is that one in which the most marginalized person can live with his head held high. And AI should actually be used for that purpose. So with this, I would stop and thank you very much. I took some more time. Sorry for that. Thanks a lot for your kind patience.
Thank you, sir, for your valuable speech regarding AI and ML. There is an announcement, and I am hand over my mic. to us, sir.
I request all of the delegates, participants, and our resource persons to have lunch at our department, and please come with us and have lunch there. And organized. I'm very happy, sir. I'm honored that you came all along from this Kolkata to here and you agreed to come. From my university, from my department, from my own. I thank you. Thanks a lot, sir.
I'm here.